Hello everybody. Today I'll be talking about the Home Controller project. This video is divided in 3 parts. The first part will cover the motivation behind the project. The second part will cover the tech architecture. And the third part is a demo of one of the project's features. So the motivation for this project comes from the fact that smart devices or IoT devices are getting more and more popular, meaning that people are consuming those devices, are introducing those devices to their lives more frequently nowadays, meaning smart light bulbs, smart TVs, even smart fridges. So all those devices are getting like a smart spin-off, and how do we control those? So definitely an answer on how to control those devices in a unified way would be getting an Alexa or a Google Home or any other of those home controller devices. But they only support voice commands, and also those are not open source, meaning that we don't have control of the information that is coming through the microphone. We don't know how that information is being used. So the motivation comes from 2 facts. The first fact is we only are able to do voice commands so far. And the second one, we don't know where the data is going, where the data is flowing to. So in order to address those issues, I created a home controller application. Basically, it's an application that enables users to communicate with their IoT devices using a web interface, a voice interface, just like Google Home or Alexa, but instead of using Google's or Amazon's hardware, we're going to be using a Raspberry Pi with a microphone, which is actually much cheaper. And finally, we can even use a BCI device, meaning a brain-computer interface, which is extremely cool. So with some machine learning and brainwaves, we're also going to be able to control our IoT devices or smart devices. So that covers the first problem. And the second problem is the fact that those other devices I've mentioned before, they are closed source, so we don't know where the data is exactly flowing to and who is using the data. So in order to address this, the whole architecture of the system will be using components that can be controlled by the user, the developer in this case, and the data can be monitored by the developer as well. So this is not going to be using, so basically this project does not use any sort of external APIs or cloud services. It's using pure big data technology that is open source. So let's jump to the second part of this video. Let's talk a little bit about the tech architecture behind this project. Before jumping into this diagram, it's important to mention that we're going to be using the system to control an IoT device called the Philips Hue. So the Philips Hue is a device that basically lets you control your Philips light bulbs in your house. It's a smart device. So we're going to be integrating with this specific device, but this architecture and this system is able to communicate with any other IoT device that has an open communication protocol, just like the Philips Hue has. So let's jump back to the diagram here. On the left side, we can see 2 users being specified, and the users, as mentioned before, they can interact with the system using the web interface, an audio interface, or the brain-computer interface. It's important to mention that the web interface is quite powerful. It's the most powerful of the 3. It actually enables users to set up their own customizable commands, meaning that I could set up a command that says, okay, whenever the user uses the word hi or turn on, you should turn on the lights. Or whenever the user says turn down, we should turn down the lights. So the web interface gives us this power to set up customizable commands for the audio interface and also for the brain-computer interface, meaning that we could set up a command that says, okay, if the user meditation state is 60%, let's change the light's color. Or let's say if the user attention span is 50%, let's turn down the light. So we can, I mean, those are vague examples, but you can basically use the web interface in order to configure those customizable commands. And also using the web interface, we can set up our own commands. So looking at the diagram here, we can see the user trigger those commands using a computer. And that computer basically talks to a GraphQL API. This API has its own database, and so if I'm setting up commands, basically what's going to happen is the web interface will communicate with the GraphQL API and will store those commands in the database. It's also important to mention that this GraphQL API does authentication of the user, and well, will basically authenticate the user throughout the process as well. And that's for the web interface. So on the GraphQL API database, we're going to be storing all the commands and the user information, and that should cover the web interface. For the audio interface here, the user will actually say a command, and we're using a package called CMU, which is an open source package. This package will be responsible for doing speech to text recognition, meaning that it will, in an offline manner, convert the speech to text, and this text will actually flow to the GraphQL API. And from that point on, we can decide if we're going to trigger a command on the Philips Hue or not. And finally, we have the brain-computer interface application. This, in my opinion, is the coolest and is also the most tricky to understand. But bear with me, it's actually really interesting the way it works. So we have this device called the NeuroSky MindWave Mobile 2. This connects via Bluetooth to an iPhone application. This application communicates securely with the GraphQL API. I mean, the user is authenticated. That means that the mind waves will flow from the NeuroSky device to the iPhone application, and from the iPhone application to the GraphQL API. From the GraphQL API, it will be dispatched to a Kafka queue. So we have a Kafka topic which will get this information in real time. This topic will be consumed by an API called the EEG API, the electrocephalogram API. This API gets this information in real time, it stores this information in a MySQL database, and it also uses this information in order to train a machine learning model. So it actually trained 3 models: a multi-layer perceptron, it trains an SVM, a support vector machine, and it also trains a random forest model, so a bunch of decision trees. And also it's important to say that the data is normalized before this whole process is done. So we have a normalizer there. So this EEG API is responsible for getting the data from the queue, from the topic, consuming the data and creating the models. But as soon as the models are ready, the mobile phone can also send EEG data to the GraphQL API, not for training the model, but also to getting inference information. So we can send mind waves, it goes to the Kafka queue. We have a separate topic for that. The topic gets consumed by the EEG API, and the EEG API will run the machine learning models in order to predict how the user is feeling, and using the 3 models. And then we, based on those 3 models, we rank exactly what is the mind state of the user. So let's jump to the third and final part of the video, where I'm going to demo the PCI application working in real time. Okay, so before using the application, we first need to log in, create an account and log in. So for now, I'm going to just use an account that I already have. So for this part of the application, we're going to just focus on the states. So the idea here is that the user, basically we want to create our own customized brainwave commands using the classifiers, which means that you can label any activity in your life. For this example, we're going to use 2 states, which we're going to call open eyes and closed eyes. But you could create any kind of state, for example, watching television or playing tennis, whatever. Like if you're using the device and you're able to classify those brain waves, this is going to be our class here. This is going to be the way we're going to classify this data. So just going to save this for now. The second option, the second part of the system that we need to be aware is the command list. So we're going to create a new command here. It's going to be a BCI command, and it's going to be an open eye. So whenever we notice our classifiers notice that the user has his eyes open, then it's going to trigger a Philips Hue command. For now, we're going to just say that whenever the eyes are open, Philips Hue is going to be true, and we're going to create a new command here for closed eyes, and whenever the eyes are closed, Philips Hue is going to be false. So this is all we need to do here on this side. Now we can go to the iOS application, and we're going to be able to train our classifiers with some simple data, and after that we're going to be able to actually run it and see if it works. Okay, now we are on the iOS device. We can just type in our username, so gmail.com, and the password, and nice, we're able to retrieve it. We're connecting the BCI device right now. Establish a strong connection. So as you guys can see, on the blue line is the meditation, red line is attention, and yellow line is blinking. Those are pre-established variables that comes with the device, but we're gonna try to extract more patterns, like by using the classifiers. So the ones that we just set on the web interface, those are showing right now in the app. So you guys can see closed eyes and also open eyes. So if I click the switch on the right, it's basically telling to classify this current EEG data, the brainwave data, as open eyes. And if I move it to closed eyes and I click the switcher, it's basically going to classify the data as closed eyes. So we're going to do that for a second and start doing some classification. So I have my eyes open right now, and I'm going to just click here. So it's telling me EEG data started being labeled as open eyes. Okay, so it's basically storing the data with this label right now. I'm going to stop for now, and then I'm going to just do closed eyes, and I'm going to close my eyes and do it with that. Okay, so that's not enough data, like that's not a lot. And right now, as you guys can see, there's no classifiers. So random forest, SMO, ML Perceptron, they are not classified, which means that right now we're generating classifiers 5 to 5 minutes. So it takes a little bit of time to get the data and generate the classifiers, but we can also see that in real time. And after the models are generated, now we can see like open eyes being classified, now closed eyes. So to trigger the commands that we establish in the web interface, all 3 classifiers must classify equally. So if they all have open eyes, then I'm going to trigger the open eyes command. If they all have closed eyes, then I'm going to trigger the closed eyes command. So I have the application running over here with the lights set up over there. We're going to do a quick test. Okay, I'm going to do like a quick test right now. So I'm going to close my eyes. I'm going to open my eyes now. I'm going to close it again. I'm going to open my eyes. Perfect.